This lesson is being broadcast live from my classroom. Yay! That was so good. This is the first ever live broadcast I've ever done. Okay, so this lesson right here. You probably could kind of figure out for yourself if you use kind of the context between the words. But we're just going to go through this quickly. This is kind of a fill-in-the-blank note. And then we've got down here, we've got a couple of rules that we can look at when we're detecting gases. So the whole premise is that when a gas is produced in a chemical reaction, we want to be able to find out what gas it is. That's the whole premise. And some gases, we can identify them, some gases we can't. So here we go. So during a chemical change, or a chemical reaction, one or more new substances are produced. Often one of the new substances made, or what's the scientific term for the verb made by a chemical reaction? Produced, yeah. Is that what you were going to say? No, but that's close, yeah. Okay. All right. If the gas is produced in a liquid, it's easy to observe because what will the liquid do? It starts to fizz. Yeah, that's right. It starts to bubble or fizz. So we can say that bubble or fizz. But just because you know that the gas is being produced doesn't mean you know what gas it is. Okay? So it'll start to bubble. It's easy to detect. Like sometimes you'll know the gas is also easy to detect if it has an odor. Like rotten eggs or sour milk, those have very, very pungent odors. It's also easy to detect a gas if it has a color. Okay, so for example, does anyone remember chlorine gas has, what color is chlorine gas? Yeah, green, that's right. And iodine gas, this one's a little bit tougher. Iodine gas is purple, yeah. All right. So then the next sentence says, many gases, however, are not easy to detect because they are odorless and colorless. Therefore, it's difficult to identify these gases by their physical properties. So a gas is being produced, it has no color, it doesn't smell, it could be any number of things. So we could identify them though, if we collected them, we could identify them based on their density. We looked at that in our first unit. We could identify it based on its density. We could identify it based on its melting point or its boiling point. Probably not melting point, because these things would become a solid. Gases usually would become a solid at super cold temperatures. So probably their boiling point, right, which is where they become a liquid, gas to a liquid. We could identify it that way. But this is very, very time consuming and very difficult to do. Okay, so what we've done is we've said, okay, we can test what gas it is based on 3 different chemical reactions that we're going to perform. Okay, and so the first thing that we're going to test, 3 standard chemical tests are for the 3 types of gases that are made most often. The first is hydrogen. The second is for oxygen. And the third is for, right. So those are the three: hydrogen, oxygen, carbon dioxide. There's tons of other clear, odorless gases, like nitrogen is another example, right? But we're not going to worry about, the only three that we're going to find a test for is these three. All right. So here's what the tests are. We're going to come down to this chart right here. So just remember that hydrogen comes first. It's got a chemical formula of H2. And this is what's going to happen. We're going to take a splint. Okay, so one of the splints, one of those wooden sticks that we have at the back of the classroom, one of those wooden sticks, we're going to take it and make it so that it's on fire. So we're going to put a flame so that it's flaming, and we're going to insert that into a test tube with hydrogen in it. Okay? And of course, hydrogen is flammable and very, very explosive. And so if there's hydrogen that's present, that flaming splint, what's going to happen to the hydrogen? It's going to explode. Okay? Now, we're doing it inside of a test tube where there's not going to be tons and tons and tons and tons of hydrogen. So we're going to get a small contained explosion, but it'll definitely be a loud pop, and that's what you're going to hear. Right? So a small explosion will occur, and basically it sounds like a loud pop. Two examples, of course, were the Hindenburg. Right? They used to fill blimps with hydrogen instead of helium, and that's a bad idea because hydrogen's really explosive. And another example of where we saw a hydrogen explosion was the space shuttle. That happened when I was a little kid, and I've got a reading for you a little bit later on in this unit that you can go over, but that was the space shuttle that was crazy. I think it was in grade 3, and I can still remember it. Still remember watching it on TV. All right, oxygen, chemical formula, O2. So the test here is a little bit different. Instead of a flaming splint, we're going to take a splint that's just glowing. So it may have a flame on it, and then you put it out so that there's just embers on the splint. We call that a glowing splint, and we're going to put that into the test tube. And of course, oxygen is required when things burn. So if there's oxygen in there, all these little embers are going to do what? Yeah, they're going to ignite. So a glowing splint, if you insert it into oxygen, will re-catch on fire. Okay? The splint will reignite. Okay, so the last one's carbon dioxide. Now, is carbon dioxide flammable at all? No. So we know that carbon dioxide actually would extinguish a splint. So, because nothing can burn in carbon dioxide. So if you took a splint and you put that into a test tube full of carbon dioxide, it would actually make it go out. However, carbon dioxide is not the only gas that would make that splint go out. So that really tells us nothing, right? So you could have a test tube full of helium, and if you put a splint in there, it would go out. You could have a test tube full of nitrogen, and if you put a splint in there, it would go out. So that doesn't confirm or deny whether it's carbon dioxide. It basically just tells us that it's not hydrogen and it's not oxygen. So we have a completely different test for carbon dioxide, and that is that we take the colorless gas and we bubble it through lime water. Okay? We bubble it through the lime water, and the lime water will turn cloudy or opaque if it's carbon dioxide. So we'll see a precipitate being formed. All right, so your task now is to read these two questions, or is to read this paragraph and to go through and answer these questions. And that'll be kind of the end of this lesson. And we're getting ready for our lab on actually using these tests. And I think we're ready to go now. All right.